Hi there, this is Lucius Laframboise from ENG Suite. I am the project manager here of QE Suite, and today we're going to continue our talk on built-in Excel functions. And to do that, we're going to use a couple of QE Suite functions just to show you some of the really powerful things that Excel is capable of. Now, you're probably already familiar with these first ones, but we're going to really be, once we learn them, chaining them together and doing some really cool stuff. And this is probably the first video where we're going to do something really cool that just kind of shows how simple it is to make some powerful things without doing any programming, okay? So today we're looking at the OR function, and there's a good joke about OR as a logical operator. So last time we looked at AND, today we're looking at OR. So next time you go to a restaurant and the server says to you, would you like a soup or salad? Say, yes. And that's something you can say because OR means if this or that or all are true, then do that. So that's when we insert it into an if statement. But what OR is saying is this or that or both. Or in this case of Excel, you can put as many entries as you want, just like the AND function. So let's jump into Excel and see how we can use this. All right, here we are in Excel, still in our variable sheet. And we've got a PPK, we've got an Anderson-Darling, but this time we've added on Ryan Joyner and Chebyshev. Nice to meet you guys. So what we're going to do here is, let's say you want to make your spreadsheet a little more robust. So that, you know, that's great that we have an Anderson-Darling normality check in there to make sure that we're passing normality and PPK. But you know, Anderson-Darling is a little more of a selective test. So let's say we want to throw in a Ryan Joyner just to double check to make sure things pass, or Chebyshev's theorem, which is a high capability exemption. Both of which are easy to use functions right here in QE Suite. And what we're going to do is we're going to say if our PPK is greater than 1.33, so our PPK passes, or any of these three normality tests pass, if the PPK passes and Anderson-Darling or Joyner or Chebyshev. So if PPK passes and any of our normality passes, okay? So in here, we're just going to come in here and we're going to take out this Anderson-Darling part. So inside of our AND function, we're going to say if PPK passes and here's where we're going to put our OR. So everything in between these parentheses, if any one of these, so if any of them are true, it will return a true statement, and that true statement will then be evaluated by AND. The result of AND will be done by if. So pause it here and take a look at how all of these parentheses are working here if you need to. But that's the basics of what we're going to do. So I'm just going to hit escape because I got a little ahead of myself there. We're going to come in here. We need a Ryan Joyner test first. So we'll do QE.RyanJoyner. And we will select our data. We'll give it a name of our dimension. Return as object, true. And then true because we want to hide our graph. Enter. All right. In here, we have our Ryan Joyner critical and our test statistic. Then we're going to run Chebyshev. And Chebyshev is going to take our data. Then we are going to take the specification, and then name will leave the same, and then hide graph true. All right, awesome. So we're going to cut this out, and we're going to replace it with an OR statement. In here, we're going to paste our Anderson-Darling test. Then for our Ryan Joyner, so Ryan Joyner passes when the Ryan Joyner test statistic is greater than our critical. So I'm just going to do that. And then or our Chebyshev is greater than or equal to 10. Okay? So all of these, so if our Anderson-Darling P is greater than 0.05, that means that test passed. If our Ryan Joyner is greater than our critical, that passed. And if Chebyshev returns a value greater than 10, that one will pass. Okay? So if any one of these is true, it'll pass a true back in here. And if our PPK is true, then we will move on to a passing value. And for this, we're going to pass because our Anderson-Darling is quite high. We've got a 0.53, which is excellent, extremely normal looking data. So that's pretty much it for the if and or and how you can really couple it for some really powerful data analysis. Thank you so much for watching. Have a great day, and please do something awesome.